When we talk about the present worth analysis, that means we have several projects and I want to select one project. How I'm going to know which one is a good project for me? Well, before we go into that, we have to keep in mind the projects are two types. We can say three, but mainly there are two types. The first one, we call it mutually exclusive alternatives. What's an alternative? That means, I can select this or that. Why we call it a mutual exclusive? That means I have to select only one project. I have no right to select two projects. Why? Because my budget, it is, let's say, $1,000, and I have to buy a phone. And all the phones around, me in my shopping cart, everyone is around $1,000. So how many phones I can buy? One phone. So therefore, I have to select only one project. So these we call them, mutually exclusive project. Okay, you have to select one project. There is another set of projects. We call it independent projects. It's like you have a $1,000 budget, and you want to buy a printer, plus a mouse for your laptop, plus a case for your phone. Okay, so you're gonna tell me if the budget is less or equal to $1,000, I can buy them all because everyone is independent. Okay. While in the previous example, only one project has to be selected. Okay, one project. Here, no, you have the right to select any as long as we say it's economically justified, and that's what we are going to explain later on. Okay, as long as it's economically justified. Sometimes you don't select any project. And sometimes, we don't want to do anything because either one is not good for me. Then we call it do nothing project. Okay, do nothing project. Now let's see some examples. Okay, let's see some examples. But keep in mind, in any project we have something we call revenues, and we have something we call a cost. Revenue is any money coming into my pocket. Revenue does not mean profit. Okay, profit is a revenue. Okay, is that clear? Profit, that means you made money. You made a profit. In addition to the cost that you were able to get back. Revenue is any money that comes into my account, including like what? Including cash inflow. Cash inflow. Okay. Costs are the cash outflow that I am paying money for. Okay, now we go back to the project. So revenue, it is positive. Cost, it is the money that I'm paying, it is negative. Because in this chapter, we care about positive and negative values. Okay, whenever you make money, it's positive. Whenever you are paying, it is negative. So if I am buying a generator, this is negative amount. Okay, if I start making money out of my generator, well, this is positive amount. I'm talking about like public, community generators or public PV, generators or cells. Okay. Now we go back to the P analysis. We're gonna solve for a project, and we are gonna see, if the PW is greater than 0, that means it's a good project. If it's a mutually exclusive. Or if it is independent project. Now, in a mutually exclusive, we're going to see, hey, any project, if it's greater than, if it is if it has the largest numeric value, it's acceptable and it will be considered, and the rest will be disregarded. So PW has to be greater than 0 if we are talking about independent project. Any independent project is greater than 0, it's a good alternative. In a mutually exclusive, I consider the largest numeric value. And that's what we are going to see in a second. Okay, let's consider the following project. We have alternative X. Okay, alternative X is a project. How much is going to cost us? $20,000. So we have to pay now $20,000. And we have operating cost $9,000 per year. What do we call this per year? We call it A. Okay, it is per year, annual payment per year, consecutive. So we call this A, $9,000. And in the future, I'm going to salvage that project. After I use it, okay, after I use the project, after 5 years, I'm not going to throw it away. No, I can salvage it, and I'm going to make money. We call it salvage value. I'm going to make money $5,000. So this is the first alternative. So how I'm going to make all those payments, cost, revenues into PW, okay, estimation? It's easy. We are looking for PW. Therefore, every payment I am getting or paying, I have to transfer it or convert it into, PW domain. Okay, if you want to look at it this way. That means how much the money that I'm paying every year is going to be equivalent to to now, okay, to the value now. Salvage value, you bring it from the future to now. How much will be equivalent now? So we do the following. We say, hey, we paid $20,000. That was initial cost. Initial cost, is it a future? Is it annual? Or is it now? Something I'm paying now. Okay. So this money I'm paying now. So it's a present worth. Because it's a present worth, guys, I'm not going to add any factor to it. Okay? Because everything is going to be in the present. And the unit of the money is a present, which is now. So I am happy here. Okay? So now we go to the second payment. What was the second payment? $9,000 per year. $9,000 per year, that means is what? It's an annual payment. So 9,000 is annual payment. I have to convert it into what? I have to transfer it to a present worth. So I have to send it from A to P. So how I'm going to do this? We said before, it's very simple. We said any A payment, what do I do with it? A payment, okay? If I want the present worth for A payments, it is A, okay, multiplied by the factor. So, A, this is A. So, now if I take a look at, A, what's this formula about? This formula is telling me if you have A payments and you want to transfer them from yearly to present worth, what do? Use this formula. Okay, so I have A. How much is A? $9,000. This is $9,000. And why it is negative? Because I'm paying. It is operation cost. I'm paying. So it's negative. $9,000. Then we use this notation. I have I 12%, yes. How many years? 5. How do I know? You go back to the question. 5 years. Okay? So this is now, I get the equivalence of A into P. Okay? So this is it. Then what else I have in the first alternative? Salvage value. This $5,000, it's a revenue. but I will get it after how many years? 5 years. So it is in the future, and I have to bring it to what? To this domain, which is the present. So I need to get the equivalent of it now. So $5,000. How do I transfer stuff from future to present? Well, it is very simple. We use the formula again. Which formula? We say P equal, F multiplied, by this factor. Okay, so this factor, what's basically telling me? Okay, good. This factor is telling me, hey, transfer F into, transfer F to P. Okay, transfer F to P. So the money in the future, we need to get the equivalent of them in the present. Do I have the interest rate? Yes. How many years? 5. So we are good. Okay, future, do you have this? Yes, it's $5,000, the salvage value. And that's what they did. So basically, every payment I'm paying for this alternative, I make it, I make it into what? Into P domain, if you want to use this way of terminologies, because some students, they like this idea. Okay, so we solve for that. We have the value of this. We have the value of this. We get it from the table. You do the math. I get the PW of the first alternative. What does it mean? That means I'm getting all the payments, okay? Whether it is now or in the future, or even the payments I'm paying every year. I need to know how much the whole amount of all those, cost and revenues, how much they are equivalent to now. Okay, the value of that is for $49,606. Okay, dollars. Okay, so it's around $49,000. This is the idea of how to get all the payments into present worth. Okay, how to get the present analysis of the second alternative? Same thing. We have the cost, we have the annual, we transfer it into the equivalent present worth. We have the future, which is the salvage, we transfer it into the present worth equivalent. And then from the table, we get this. So now, because they are mutually exclusive, that means I have to select. How do I know they are mutually exclusive? Because I have to select only one project, one and only one project. So what do? I look at the values. This is negative 49, and this is negative 45. Because they are both negative, I choose the largest numeric value. Which one is larger? Okay, numeric value. Negative 49 or negative 45? Negative 45. Okay, it's closer to 0. In other words, what's better for me? To pay for a project negative 49,000 or negative 45,000? For sure, negative 45,000. It's better for me. Okay, guys, if it were to be positive, I will select the highest. If this were to be positive and this positive, I will select the highest. When they are negative, I select closer to 0. Okay, that's why we call it largest numeric value. This is the way we solve a present worth analysis. Now, something you have to be careful about, guys, here. We are comparing two alternatives. The first alternative is X, and the second alternative is Y. The comparison was easy. Why? Because it is the same lifetime, the same service life. That means the first alternative will last 5 years, and the second alternative will last 5 years. The question would be, What if one of them will last 15 years and the other one will last 5 years? Which one is a good project for me? Example, let me give you an example. You want to buy a phone. You have Android phone, $1,000, and you have iPhone, $2,000. You look at them, Android is $1,000, Apple, $2,000. You know, very similar features. Which one is a good project for me? If you tell me right away, hey, you know, $1,000 is good, that's not a good question. That's not a good answer for my question. We have to do, you know, analysis. How? You are gonna tell me if, you know, if this, you know, the service, you know, the service life, okay, of these phones, okay? How long this phone will last, as we're going to see later on. We're going to use LCM. How long this phone will last. If Android phone will last only for 2 years and iPhone will last for maybe 7 years, well, you know what? Oh no, iPhone is better than Android in this case. Unless you want to tell me, hey, I'd like to change phones. That's a different story. So before you do any comparison, guys, you have to make sure, do I have the same life cycle or no? If I do, we do what we did here, okay? If I don't, then I have to use LCM. I have to use what? LCM. What's LCM? LCM, actually we can use LCM, or we can do study period. Study period, if you decide how many years you want those to be, you know, studied. Should I do my estimation based on 3 years, 4 years, 5 years, 6 years? We're going to see later on that. Or we use life's LCM, okay? Least common multiple. Example, let's do an example so you understand what I'm talking about. Those are two alternatives. One is 3 years, the life of the project. The second one is 6 years. So which machine will fail before the other? Machine A will fail because the life of machine A is how many years? 3. So after 3 years, this machine has to be sold. It's not good anymore. While machine B will last 6 years. Okay? So it's like buying a Honda car or Kia car. Okay, with my respect for all, you know, manufacturers here. But you can tell, hey, you know, one is better quality than the other, supposedly. So what should I do in this situation? It is very similar to the previous one, except at year 3 here, guys, you know, we have a problem. Okay, what do I mean by that? Okay, look, forget about, okay, let me help you out here. Delete this. Oops. No. Okay, it's very good. Delete. Let's do the following. Okay, copy, paste. Forget about whether it's 3 years or 6 years. Let's solve this, you know, as if we are doing every project is 3 years. How are we gonna do it? We are gonna say we have a $20,000. It's a cost. They said it's first cost, so it's negative 20. And because we need all the payments to be in present worth, $20,000, what is it? Is it a present, A or F? $20,000 is now, you know, I'm paying it now. It's a first cost, it's initial cost. So it is P. So I put here negative 20,000. Now, also for alternative A, I pay every year 9,000. This 9,000 after a year is different than 9,000 after 2 years. It's different than the one after 3 years. Why? Because every year we said there is an interest rate. So therefore, I cannot just add $9,000 plus and multiply it by 3. No, there is interest. So therefore, I have to use what? A formula. What's that formula? Is $9,000. We have to transfer A into P. Okay, we have the 10%. And how many years we said? Okay, 3 years. Okay, for simplicity, I'm saying here, for simplicity, okay? I'm not using two alternatives. I'm just solving for one alternative.
Doctor, usually we want to... Yes.
Here we have the payment. I said we are only doing for 3, so not for 6. Later on we'll do for 6. So this is now 3. And what's left? So we did this. We converted this into PW. We have 4,000. 4,000 is future. So, as I said, we don't need this anymore. Okay. So the future here, 4,000. Okay. And the year is how much here? 3. Because we are doing it for 3. This is the way we usually do it typically. This is good if machine A is a 3 year and machine B is what? 3 years. But in reality, now it is not. We have what? We have different years. We have a 3 and 6. So what do? I say, you know what? Everything now has to go to 6. Okay, so I'm paying, how many A's I'm paying per year? How many? 6, because 6 years. So I have 6 payments, not what? Okay, before I do this, maybe I went a little bit, faster. Why here I said LCM is 6 years? Why?
Because it is the greatest?
Because
I will pay money for 6 years, not for 3 years.
What's the LCM between 3 and 6? We have a 3, okay? 3 can go to 6, then 9, then 12, then what? 15. For 6, what do we have for 6? If I want to check the LCMs, it is 6, 12, 18, okay? 24, and so forth. So if I take a look at this, guys, what's the common between the 6 and the 3? If I want to check the LCM.
6 and 12.
6 is 6. I have to make 3 the closest to me, 9 or 6?
To 6.
Exactly. So that's why I have to make my life cycle 6, okay? So 3 is not anymore 3. In order to compete with the other alternative, I have to use the least common multiple, which is what? After 3,
6.
right away, 6. If you use 9, it's extra 3 years. We don't want this because we have 3, 6, 9, 12. Okay. So let's say now if I have, this is 6, this is a 3, and this is what? Okay. If I have, this is here 2, and this is here 4. What's the least common multiple?
4.
4. And let's say now this is 4, and this is 2, and this is 8. Or, okay, 8. So what's the least common multiple?
8.
We say 2. After 2, what do we have?
4.
4. Then 6. Then
8.
If I
so 8 is closer.
Yeah, if I do this, how many cycles I will have? I will have 2 and 4. This is the first cycle. So I will have several cycles here, okay? But between 3 and 6, how many cycles I will have?
1.
Yeah, 1 extra cycle. That means total 2.
طب يكونوا أكتر من cycle شو بنعمل؟
I'm showing
مثل
it.
2 وال 8.
I'm showing. Usually, we don't want to go that route now. Now back to here. We can see here, this is our 3, 6. The least common multiple between 3 and 6 is what? 6. So therefore, I have to have another life cycle. If I go back to the drawing, this is my payment, first cost, okay? Then I have every year, I'm paying 9,000. if the cycle is only 3 years, how many payments of A I will have? I will have 3 payments. 1, 2, 3. Now the cycle is 6 because I'm trying to find a common life cycle between the two projects. One is at 3 and one is a 6. We decided it is 6. So now I have to extend the life of my machine. How I'm going to extend the life of my machine? At 3, I will sell my machine. If I sell my machine, how much is the salvage value of it? $4,000. So here, I'm going to sell my machine at $4,000. And in order to continue extra 3 years, I have to buy another machine. So here I will buy what? Another machine. Okay? So I have here to sell and buy. Okay, very good. So I sell something. It is negative. I mean it's positive. And I bought something. So selling and buying, here I have to be careful. I sold my stuff $4,000, that's positive, and I had to buy a new one, $20,000, that's negative. What's the total? The total is negative 16. That's why we have here negative 16, because at year 3, in the end of the first, the end of the first life cycle of the machine, the machine only lasted 3 years. So at 3, I have to sell and buy another one in order to extend the life of it extra life cycle. That means 6. So that's why here I am selling, I'm buying, and also I have the annual payment. And that's why here we have annual payment, 6 payments, because it's 1, 2, 3, 4, 5, including the year I'm selling and buying. And also at year 3, I am selling and buying. So it's 4,000 minus a 20, negative 16 at year 3. And here it is future. So I have to send it back to what? To present worth. And that's what I did here again. Okay? I'm sending it from a future, transferring it, okay, to present. Then at year 6, what I'm going to do? Sorry, this is year 6, okay? What I'm doing here, I am at year 6, what I'm going to do? I'm going to sell my machine. So that's why $4,000, also by the end of the 6 years. So $4,000, and I'm all set. Go to the table, get the values, and you get this. So back to the table. If I want to finish the table here, this is 6 years. So I have a life cycle, 3 years. Then another life cycle, 3 years. 1, 2, 3 years. Okay? If you got confused before. So we have at year 6, what I'm going to do here, I'm going to sell my next, life cycle machine. And it is going to be also the same salvage value, 4,000, and I'm all set. Now, how I'm going to get the present worth, that means all the payments for the second project. Also, it's easy. Okay, we have the payment, 30,000. We have the A's, we transfer them into PW, that means from A to P. Okay, and we have the salvage, you transfer it from F to P, and that's it. Which one I have to select? I have to select the largest numeric value. Between negative 68 and negative 57, I will select negative 57. In negatives, I go closest to 0, which is less cost for me. Okay, this is the idea of present worth analysis. Any question?
Doctor, الكومباوند.
Another one thing quickly, if they don't ask us for LCM, this is LCM. Okay, if they ask us, we can see 2 different project life cycle. This is 3 years, this is 6 years, but yeah, they don't care. They tell us, I want a study, for 3 years of every project. So what do I do? Okay, very simple. This is very simple. Because we said we have least common multiple or, study period, specific study period. So this is very easy. The only trick thing is you have to tell me how much you need, let's say you need a study period for 3 years. You have to tell me how much is your salvage value. What do I mean by that? If you have a car now, if you sell it after 1 year, maybe you can get $10,000. If you sell it after 10 years, the salvage value is going to be more or less? It's going to be less, isn't it? They are telling me the salvage value of the car is $6,000 after 6 years. If the study period said, hey, I don't need 6 years, I need 3 years, the salvage is going to be the same? No.
No.
So typically it should be more. So someone has to tell me, hey, how much is it? Okay, and that's what they tell us. Hey, if I take a look at the slide here, they are telling us the salvage value. Okay, they are telling us the salvage value here is $4,000. Okay, after 3 years. Okay, they are telling us here, after 6 years, it is $6,000. If the study period were to be 3 years, how much they are giving us the salvage value? $10,000. And then we solve it as we did with the other one. But there is no need to create another life cycle of a 3, because the study period is for how many years? 3 years. That means they are telling us this is 3 years and this is now 3 years. Just be careful of the salvage value. Is not 6,000 anymore. It is $10,000, and this is given for us. This is the main idea of the study period. Then quickly we go for something we call it capitalized cost. Capitalized cost is when P equal to the annual payment, and then you divide it by I. Okay, and when do we use this? When we have a long period of time, infinite. So I cannot anymore use this formula. If I go to this formula here, usually I have n here. If n is infinite, I cannot use this notation. So what's the solution? If n goes to infinity or long time of a project, I have to use this notation, P equals to A divided by I. In order to understand this, let's jump into this question. We have 2 different machines. The first machine will die after 3 years. Okay, the life cycle is how many years? 3. The second machine, it will stay forever. Okay, it stays forever. The first machine, how I'm gonna solve it? Okay, because they tell me in the question, okay, the topic is about capitalized cost, I have to keep in mind, I have to get what? I have to get A, then divided by I. So the present worth is A divided by I. So first of all, I get the A here for all of these in machine 1. Now, $20,000, is it the present or A value? I have to transfer this, present worth into to A domain. So now I go from P to A. This is the $20,000, and this is the factor to transfer it to the equivalent of A. Then I have $9,000. It's already what? It's per year. Therefore, it is an A. I don't have to do any multiplication here, no need for a notation. Now the salvage in the future, I have to send it to what? To A domain, okay? I have to get the equivalent of this in A. So the $4,000 transfer F to A. And I have how many years? 3 years. 3 years, and I is given. I got A. After I got A, what do I have to get? I have to get P. And what we are solving here, we are not solving a present worth. We are trying to find capitalized cost. Again, let me repeat. We are trying to solve for capitalized cost. That means what? That means I'm trying to search for CC, okay? Okay, CC. That's what I'm trying to solve for. How to solve for CC? You get A of the machine, okay, first machine, and then you divide A by I. Why? Because the capital cost formula says it is A divided by I, okay? So we are done from this. We got a capitalized cost for machine 1, $15,000, okay, divided by the interest rate, 10%, that means it's 0.1. I got CC1. That means capitalized cost 1. What about the second machine? Way much easier. Second machine, we say, hey, capitalized cost is what? A divided by I. So this is already P, so I keep it as is. Then this is what? A. Okay, A, you divided by what? By I. This is the formula. Divided by I. Okay? So now I have the present cost, and then I have this capitalized cost, A divided by I. I'm all set. Even if they give me a salvage value, I do not use in capitalized cost. Imagine now if I have, a phone after 50 years, how much is the phone? Negligible, unless it's antique, So this is the last point in this chapter. Thank you.